Yeah, so now let's have a look at circuit multiple choice question with brightness. Yeah. They told you key information is these three lamps, they have identical resistance. Here they have identical resistance, and they ask you when N breaks, what will happen to the brightness of L and M? So whenever they ask you the brightness in the exams, brightness just tells you the powers, and the power P, there are three formulas. It equals to voltage multiplied by current, equals to V squared over R, and equals to I squared over R. And you need to decide in which case, which one is the best one to use. Yeah. So first of all, we're going to draw two diagrams before and after it breaks. Yeah. So before it breaks, it's just a normal three lamp circuit. Three lamp circuit. So if this is a resistance R, this is resistance R, this will be resistance R, and then you can see this resistance in total is R over 2, and this resistance R. Okay, so if their resistance is 1:2 ratio, it's in a series arrangement, and we know series arrangement current is the same everywhere. Okay. If the current is the same everywhere, then their voltage ratio is just going to be 1:2 ratios. Okay, so that's just their voltage ratios. And if we just say, oh, the battery has an EMF, this part have an EMF of a third EMF, and this part here will have 2/3 of the EMF. And then now let's have a look at it when N breaks. Okay, so after N breaks, there is a dramatic change in the circuit. Now we just have the top two resistance. Okay? So this is R, this is R. Okay? So the first thing you realized when N breaks is the total current is changing. Okay? So I, in this case, decreased. Okay? I decreased because previously we have R plus R, right? Yeah, so we can see it's R total equals to 1.5 R. Okay, it's 1.5 R. Now the new R total equals to R plus R equals to 2R. Yeah, so they have the same battery with EMF sigma, and the R total become 2R compared to 1.5 R. So I total must decrease. Okay, I total must decrease. And now let's have a look at their corresponding voltage. So this one shares a half EMF, and this one also shares a half EMF. Okay, so they both share a half EMF. And now we have all the information we need, and let's try to compare them. Okay, we'll just compare them one by one. We're going to compare our light bulb M first. Okay, light bulb M. So this is the M before, and then this is M after. Okay, this is M after. So for comparing M, we have the formula P equals to VI, V squared R, I squared R. Okay, yeah. And you can see it's probably the best to use, you can either use this V squared R or I squared R. Okay, either is fine. So let's just compare them, see if they give the same answer. For the light bulb M, if we're using P equals to V squared R or I squared R, okay. So if we're using P equals V squared R, R never change, right? R just the resistance of the light bulb, that doesn't change. And the voltage before is 2/3 of the EMF, now a third of the EMF. V goes from 2/3 to a half, right? 2/3 of the EMF to a half of the EMF. V decrease, R stay the same. The power is definitely going to decrease. Or if you look at the current, okay? Or you're going to look at the I squared R. And IR, and so the light bulb M is in the main branch. So the current goes through M just equals to total current. It just equals to total current. And we said because the total resistance become 2R, therefore I total decrease. Right, because I total decrease. So when the I total decrease in this case, the resistance of the light bulb stay the same. So I decrease and R stay the same, and therefore the power is going to decrease. Okay, the power is going to decrease. So it follow exactly the same thing. Okay? So you can see, doesn't matter you use V squared R or I squared R, this give you the same answer. Okay? So the brightness of M, it will just going to decrease. Okay, so we're going to choose one from A or from C. Okay, so let's see whether it stay the same or it's actually going to increase. So now let's come back to this light bulb. L, okay, L on the top. So it's just this one here, it's highlighted. So this one, this green circle, and this green circle. Okay, this green circle and this green circle. Yeah. So now let's think about what's happened. Okay. We can use P equals to V squared R or I squared R. Okay. Yeah, we're probably not going to use I squared R because you can see the current is a bit complicated to work out. So we don't want to do this one. I mean, you can just going to take a long time. Probably the best way is using V squared over R. Okay. They have the same resistance. All you need to do is just compare their voltage. So before, the voltage is a third of the EMF. Right? And then now the EMF goes to a half. Okay. Now the EMF goes to a half. So you can see EMF dramatically increase, R stay the same. Therefore, power is going to increase. If power increase, the light bulb L just become brighter. Okay? So L, the brightness will just increase, it become brighter. So we choose C for this question.